Drone swarms have captured the imagination of researchers worldwide, with promising applications in autonomous coordination, surveillance, and exploration. Yet, despite the excitement, most researchers still struggle with the basics, getting drones to fly reliably. Some succeed, but often only with the help of expensive motion capture systems. To bypass these limitations, researchers often build DIY drone swarms, but this demands large team effort. Smaller commercial drones allow easy deployment, but suffers from connectivity issues like video jamming and unstable links. This raises a key question: can we develop an affordable, stable, and practical swarm system? To address the issue, we introduce a low-cost, scalable solution using RealSense cameras, commercial drone like Teo, and run them with AirSwarm system. Instead of motion capture, drones localize within a pre-mapped area using drone onboard monocular camera-based relocalization. Each commercial drone that may have IP conflict, we equip them with a Raspberry Pi to deconflict the IP over Wi-Fi links. Then all drone operates under a centralized Jetson Orin for planning, control, and swarm coordination. At last, user can upload their algorithm behind to do the swarm experiments. We demonstrate our system with an NTU formation flight. Scanning takes 2 minutes, setup 1 minute, and then drones fly autonomously, proving the system's efficiency. To validate robustness, we reproduce results from the ICRA 2023 paper on non-cooperative stochastic target encirclement. Teo drones frequently lost connections, leading to only 3% success with CCM SLAM. In contrast, our MLE-based approach achieves over 90% success rates, demonstrating superior reliability. A key issue with CCM SLAM is its reliance on map-based estimation from backend or BSLAM, making it vulnerable to intermittent connection losses. Our method uses MLE-based estimation, allowing drones to recover after a 2-second dropout, ensuring resilience in real-world conditions. Our system offers a cost-effective, reliable alternative for drone swarm research. System will be open source soon. For more details, check out our paper. Thanks for watching.